Greg is the director of product marketing at GridGain, and he's going to actually introduce us to Control Center, right? Or like basically techniques how to manage and troubleshoot Apache Ignite in production. So Greg, hand over the stage to you.
Cool, thanks Dennis. Hey everybody, welcome to Ignite Summit. I guess it's almost over. So hopefully you guys have seen a bunch of great content, learned about a bunch of new cool tips and tricks, learned about some really exciting things that are happening with the Ignite roadmap from Val. So just to introduce myself again, I'm Greg Stachkick. I'm product manager at GridGain. And I'm responsible for our tools. So historically like Web Console and Visor, and now GridGain Control Center, which is our current management, monitoring, and troubleshooting tool. And we just had a big release yesterday, actually. We'll be using it during our demos. So this session is going to be all about looking at ways that we can troubleshoot Ignite using tools. So the agenda we'll be following is, we'll just give a very brief overview of the Ignite architecture, GridGain architecture. You've already been through a day of sessions, so you probably have already familiar about how Ignite works. And then we'll look at how tools can help us with troubleshooting basic different scenarios. And we'll introduce GridGain Control Center, which is a troubleshooting and monitoring tool that's built specifically for Ignite and GridGain. And then we'll go into a couple of demos, different two troubleshooting scenarios. So one is we're going to troubleshoot a slow running transaction. And we'll look at how we can take advantage of application tracing that was first introduced in Ignite 2.9. And we'll go into the details about how that transaction is executing and then look at ways that we can fine tune it so that it performs better. And then the second scenario that we're going to be looking at is SQL. So we'll have a cluster that has quite a bit of data in it, and we'll run a couple of queries. And then we'll look at how we can improve the performance of those queries by analyzing statistics and testing out a couple of different types of queries. So that's the basics. And then we'll do Q&A, and that'll be it. Hopefully you will have learned a lot of cool things about how you can troubleshoot your Ignite applications. So to start, Ignite and GridGain. So what is it? So Ignite's a memory-centric data platform. It's used to build fast and scalable, resilient solutions. And it's really flexible. It can be used to bring speed and scale to new and also existing applications. And so some of the common features that you might be using as part of Ignite are things like distributed memory-centric storage. So having the ability to load gigabytes or terabytes or petabytes of data in memory. And then do very interesting things with them. Things like running machine learning operations or running compute tasks. Ignite includes co-located compute so that you can run your compute operations in the same location as where the data resides. And so you then can eliminate a lot of your typical bottlenecks like networking and other things. It also supports a few different interfaces to kind of work with that data. So we support key value. And we also support SQL. And I suspect that a lot of you have come to Ignite because of that support for distributed SQL. And we will focus on SQL for one of the troubleshooting scenarios. But then also kind of built on top of Ignite are the GridGain editions. And they bring some additional enterprise features to the platform. So things like advanced security, the ability to replicate your data across different data centers and across clusters, the ability to do upgrades of versions of the platform with that zero downtime through rolling upgrades, and then also a bunch of features that are specific to persistence so that you can do things like back up your data, set restore points, do point-in-time recoveries, things like that. So that's just a basic of the platform. You've been already kind of working with it all day. But then along with that platform, in order to properly monitor and manage it, we need tools. And so developer tools can help us, or IT monitoring tools can help us understand what's happening in our clusters at any given time. We're going to be using for our demos GridGain Control Center, which is a monitoring and management tool that's available both as a hosted solution, so a kind of a SaaS service, or as a downloadable package that you can just run locally or run within your data center. And so when we're working with monitoring, some of the things that we want to know about are the important metrics that are happening that are specific to our use case. So back in Ignite 2.9, so I guess that was last year, we did a big re-architecture of our metrics framework. Traditionally, it had been using a proprietary metrics format. And we decided to move to an open standard based around Opensensus. So now you have, in terms of monitoring Ignite, you have two options. You can still use JMX like you may be using today, or you can also use Opensensus-based metrics. And the reason why that's interesting is that because it's based on an open standard, a lot of third-party tools have already defined Opensensus exporters, so you can connect your cluster in a tool and then pull in the metrics in a very easy way. And so as part of that metrics kind of redesign using Opensensus, you now have 200 to 300 different metrics that you can pull from your clusters. And so Control Center gives you a very simple and flexible way of building dashboards for those metrics. So if you're doing things around CPU usage, or you need to monitor your heap and off heap, or maybe you're concerned about like your threads and how your thread pools are performing, you can very quickly, just by dragging and dropping and deciding on your visualizations, you build up some custom dashboards to see what's going on. And that will give you a perfect view of what's happening now. Hand in hand with that would be to define alerts, because in addition to being able to monitor the metrics from our running system, we want to know when a situation might be brewing that might lead to a problem. And so in that case, Control Center also has a pretty flexible alerting framework where we can pick individual metrics, define some conditions, and then decide once one of those conditions have been violated, how do we want to notify members of the team? So we can check via email or SMS or other things. So between dashboards and alerts, we have a good sense of how the cluster is performing now and trends that might be brewing that might be a cause for concern. Now, if you're using GridGain additions, then you have some additional features available to you. One of them is around disaster recovery and backup. So that's using a feature called Snapshots, where you can kind of take the state of your cache data and back it up, so that if the cluster was to either have some data corruption, or it went down, or you need to restore a node, then you can just very simply restore from a specific point in time. And then lastly, in terms of kind of like the features of Control Center that we're not going to get into too much detail today, there's cache data distribution. That's actually pretty useful for troubleshooting, because you may notice that when you're monitoring your nodes, maybe one node is starting to either maybe consume a lot of memory, or a lot of load is happening on one node versus the others in your cluster. One way to start to kind of figure out what's going on is to go look at the data distribution. So within Control Center, we have a cache-specific view that will allow you to look at the cache configurations, but then also look at how the data has been distributed, the partitions, the backup partitions, and the keys across your nodes. And sometimes that can give you a hint, like if all of the data, if all the partitions are sitting on one node and another node is being unused, that gives you maybe an idea that something might be going on either with the cache configuration itself, or your baseline topology, or you may need to run some sort of rebalance event. And the tools within Control Center will help you resolve those issues. So those are some of the basic features that we're not really going to get into, but now let's actually get into some things that we're going to troubleshoot. So specifically, let's start to think about how can we troubleshoot poor running transactions. And so how we're going to take advantage of that is we're going to look at tracing. And so what is application tracing? So tracing is really just another tool in your kind of troubleshooting toolbox. Typically when you're doing troubleshooting of your applications, you might be looking at logs. You might be using a debugger. You might be pulling thread dumps from your JVM. And then the last one is if you're trying to follow an API call, tracing can be very useful because what it's doing is it's starting with an API, and then it's following the execution at each step of the call stack and recording information about the execution. And so maybe in a monolithic application, tracing isn't quite as interesting because maybe you're just in a single JVM and a debugger can allow you to just place a breakpoint and follow the execution very simply. But when you're in a distributed system, like in a large Ignite cluster, you might have an API that starts on one node. It might pull some data as part of a SQL query, but then it needs to go get data from the cache that's on a second node. And so it goes, the API call jumps over to that node, which might be in a different JVM, jumps back to the first node, might go to a third node, might go to a fourth node. And so this is, as the call is bouncing around that cluster, it might be actually hard to follow what's happening just by looking at like logs or just by looking at thread dubs or just by trying to attach a debugger to different JVMs. And so tracing helps us get that picture in a more kind of unified manner. So within Ignite, we have instrumented our tracing using Opensensus. And so what is Opensensus? Well, it's an open standard. It's a set of libraries that that has been instrumented against various languages like Java, Node.js, C++, Ruby, things like that. But it's also very flexible so that you can instrument your own custom code to be able to pull tracing and span information as well. And the nice thing about supporting an open standard is that a lot of third-party tools have already provided exporters for Opensensus. So you can actually use lots of different tools to do tracing analysis of your Ignite clusters. Now, specifically what was done to support tracing in Ignite? Well, we have, as you're well aware, there's many different API packages within Ignite. Things like transactions, discovery, SQL, cache events. And so within those APIs, we instrumented them to provide a basic set of information. So a trace is really just a collection of spans, and a span is the unit of work. And so within a span, we have some basic metadata, such as the API name. So that was where the API that was being called. Might include some information about the node, so where that API call executed. Important, will capture timing information, so when did it start, how long did it take to execute that step of the call stack. And then some status, did it succeed, did it fail, are there some stack traces that we can pull, and what are the logs? So starting in Ignite 2.9 and all the way up through 2.10, we've been continuing to add additional API instrumentation to support tracing. So how do you enable tracing within Ignite? Very simple. So you have to be in one of the minimum supported versions, so GridGain 8.7, Ignite 2.9, and you just have to add the Ignite Opensensus library to your class path. It ships by default in your libs optional directory. You just have to copy it to libs, restart your cluster. And then you also actually have to make sure that the tracing SPI is in your cluster configuration file. So I've included just the call that you need to add here. And also, if you can get my slides afterwards, I have a link to the documentation of where that's defined. And then, so once your cluster is enabled for tracing, you just need to decide which APIs you want to collect traces on. So there's two ways to do that. One is by calling into Control-SH. And from Control-SH, you can call tracing, define the API, and then just determine like the sampling rate. Or you can do it very simply within Control Center just by clicking a toggle. One note about sampling rate. So what that means is that is the percentage of API calls that you're going to collect spans from. So if you're running on a very active API, like you have a ton of transactions running in your clusters, probably don't want to set the sampling rate at like 100% like I have in my screenshot here. You probably want to set it pretty low, especially if you're doing tracing in a production environment, because it can add to overhead. But in my demo, because it's pretty simple stuff, I'm just going to collect every API. So let's do a demo. So I'm going to switch over to, I'm going to start with IntelliJ. And so here I have a very simple class that is going to create my cluster. Let me start that, and I'll explain what's going on. And then it's just going to do 2 events. It's going to do a cache get, and it's going to do a cache put. Pretty simple stuff. And let's just look at the console output. Hopefully we'll start to see some transaction notes coming out. I should have a print line statement here, yep. And yep, okay, good. So we're starting to see that some transactions are committing. And so now let's go and monitor this thing. So I'm switching over to Control Center. I'm using the Control Center SaaS. So this is our hosted managed solution for Control Center. You can simply just go to control.gridgain.com, create an account, connect up your clusters, and get like immediate monitoring and troubleshooting support. So I can see here in my clusters view that I do have one cluster that's active. It's just only has a single server node. And then I'll just very quickly look at the dashboard just to get some very basic metrics. So what I'm seeing here is that, I have one node. It's Ignite 210. I can see where it's running locally. And then I can see some very basic metrics, like I'm capturing like the thread information, the heap usage. I have a little table that's showing heap versus non-heap. And I've also got a heat map that's showing my CPU load, so that as CPU creeps up, this will color code. And it's actually pretty useful if I have a very large cluster, because then I can define some heat maps around individual metrics and very quickly, just by looking for green versus red, see if there's a problem. And then I created a couple of other dashboards, some around storage usage. If you were in my tutorial yesterday, you would have actually built up this monitoring screen around kind of storage and write-ahead logs and disk storage and stuff like that. And then also I have a visualization for rebalancing. So this is, as we're adding and removing nodes, or as we're changing the baseline topology, we may want to know if a rebalance event is happening. So some very basic things. But what we're really interested in here is actually debugging this transaction. So I'm going to switch over to my tracing view, and I can see that we're collecting over the past minute or so a few different transaction events. So if I go into configure tracing, I see it's already been set up. It's collecting all of the transaction calls. Now let's just pick one of these guys. So I'll say I see that I have a trace from the transaction API, and then I'll expand this down so we can start to look at the span details. So what are the important pieces of information here? Well, one, we can see how long it took to execute this transaction. It took 10 seconds. That's pretty long. And so now as we get the breakdown of the individual steps, we can click down into these spans and get some information, like which node did this execute on? Did it time out? Did it have an error or anything? It actually ran okay. So we can see here, now we're starting to get the cache get, right? So we're getting ready to read. And then we're going to prepare to do our cache write. We can see that the execution is happening really, really fast here. And then it jumps 10 seconds later. And then it finally does the cache put. And then it just finalizes the transaction. So what was happening here? Well, this gives us a hint that somewhere in between the read or the get and the write and the put, cache put, there is some sort of problem. So let's go back in the code and take a look at maybe what might be going on. So here's our get and here's our put. Well, what do we have here? Okay, so demo. I introduced a pause in my thread. So it has a 10-second wait. So this gives us an idea that between these lines of code, there was a problem. In this case, it's just, I inserted a sleep. So let me just change that, save, and let's go and restart. And now hopefully we'll see some transactions happening just a little bit faster. Yeah, we do. Look at that. Okay, so let's go back into Control Center. You can see we're getting quite a bbig queue of traces because I'm collecting 100% of the traces. You can see it's getting very fast, but these things are taking only 100 milliseconds. So let's pick one of these transactions. we see now the spans are much shorter. Still, we can see it's a pause between the get and the put, but then we can, see how the rest of this executes. I'm going to stop collecting traces because this is probably going to overload my storage. So we'll stop collecting traces, and at the same time, I'm going to stop this transaction runner. And I'll start up some VMs for my next demo. So what do we see? Well, what we were doing was, we were looking at some performance issues. We enabled tracing on our transaction API, and then we were able to get information about those traces and the breakdown of the API call for the individual spans. And we were able to look at the timings to see where in the code we should start our investigation. So, tracing isn't a silver bullet, but it does help us get to the root cause faster. So now let's take a look at some SQL. Another feature of our control center is that it gives us basically like an integrated SQL IDE. So this is giving us a way to define SQL queries, execute them, and check to make sure that they're executing properly. It also gives us a view of any running queries that might be happening in this cluster. And these are queries that didn't necessarily start from within Control Center. These are any query that's executing. So that can actually be quite useful because I might want to know if an individual query is taking a really long time or is stuck or anything like that. And so that's a good view to monitor. And then lastly, we collect statistics on those queries. So as I am executing these queries, we will collect some information like the success rate, failure rate, how long it took for them to execute, and things like that. And that's really where we're gonna go next. Okay, so I've got, looks like, do I have my server running? Oh, it didn't start. Let's see. Let's try this again. Okay, now let's switch over here. Hopefully we have something running. Okay, we have one node. Okay, so let's take a look at our SQL. So what am I seeing in here? Okay, so this is something good. So here I'm in my SQL tab, and I can see from my connection that I have a connection to a cluster. So my cluster here is called Inspiring Tesla. It's just an automatically generated name. If you're configuring your clusters to have a specific name, then they'll show up, the right name will show up here. But then what I'm seeing here is information about the node that I'm running on. I can see the caches that have been defined, and I can see the schemas. So let's just try running a simple query to return all the rows in person. Let's see what we have here. Oh, my partition was lost. Okay, let's try something here. Try restarting. Okay, is this running? Yes, one. And let's try again. Let's just see, do we have any data in here? Okay, excellent. So I just did a quick check to see that I have actual data in here. So in this person table, I've got, about 800,000 rows. That's pretty big. And let's see, so in interest of time, I'm just going to do a quick query just to return some of the people. Okay, so we can see here that it executed okay. We've got a couple of names in here. I'm going to grab one of these. And so you can see here, we can scroll through the results. And let's see here, how about running queries? No more running queries. Let's see what's going on with my cluster. Looks fine. Any more running queries? Nope. Okay, and then statistics. Okay, so we were able to get the count of people, so that's good. Let's try running an individual query. Let's do a search for one of these email addresses. Okay, so that was able to complete. Let's look at the statistics about that. So we did just a very simple search for an individual email address, and it took 5 seconds to complete. So maybe that's a little bit too long for what we're comfortable with. And so let's go into the explain plan and get some more information here. Okay, so this is giving us a little bit more information about the MapReduce operation. And what we see is that when we're searching through our list of people, we're using a scan query. So that's a pretty slow way of doing searches against this data set. So we might want to improve our performance by adding maybe like an index. So maybe I'll go in here and just say, let's create an index on email. So this might take a little while because it's 800,000 rows. So we're going to be indexing them. And so once this is completed, then we should see that it completed okay. Okay, that's great. Let's go just run that again. And now we see it's 3 milliseconds. Much better. So what did we do here? We basically used some query tools to construct some queries. We checked the count to review how many rows we have. And then we basically very quickly analyzed statistics, added an index, and then ran it again to see that the performance improved. So wrapping up, so what do? We understand that tools can help us with maintenance, with troubleshooting of our distributed systems. We looked at a couple of individual troubleshooting scenarios, one around tracing, where we identified a bottleneck in our API call, and then another one where we used query statistics to analyze how our query is performing, and then give us some hints about where we might want to improve our data, maybe by adding indexes and other things. So let me open it up for questions.
All right. Let's wait for the questions. Folks, if you have anything to ask Greg about, feel free to share your thoughts, questions, etc. in the chat window of the stage or either event tab. By the way, yes, you can challenge Greg with anything related to the monitoring management and, as we've seen today, troubleshooting of Apache Ignite. Yeah, that's actually it looks funny, like, but one of the first reasons why many experience SQL performance issues can be a missing secondary index. And the demo that you showed, it's probably the first thing you need to check. So guys, just take this, write this down in your checklist, like optimization checklist. If you see any issues with SQL, just check, some of the obvious things like secondary indexes. Only after that, you can start looking deeply and what's going on. Probably you need more memory. Probably you need, to update your SQL query. Probably your tables don't have data collocated. Many things to note. All right, so looks like there is a question. Yep, we often run into this error in our Ignite cluster. Baseline topology of joining node is not compatible with baseline topology in the cluster. We run our cluster in Kubernetes environment. Anything to look? So here is, Greg, you want to take this question, or I can take it?
Oh, I mean, if you want to answer, that's fine, Dennis.
Yeah, I can, because I guess that I understand what's going on. Anitha, so generally you should be getting this exception when, first thing first, I do believe that you're using Ignite native persistence, because otherwise it doesn't matter whether all your nodes are restarted or not. And most likely you see this exception when some of your nodes, let's say, went down and you're trying to bring them back. So this exception says that, let's say you have a cluster of 3 nodes and you had persistence enabled and they kept all the data, but right now something has changed, probably Kubernetes, killed one of the nodes. And when the other node is going back, it's kind of does not belong to that baseline topology. Check this, make sure that in your Kubernetes environment, your persistence files are stored in, I don't know, on some drives or SSDs that are shared among the Kubernetes pods, because that new node that might be starting instead of the failed one might have a clean persistence, like clean disk. It might be creating a different volume of persistence. And that's why when this node tries to join your cluster, the cluster doesn't recognize that node because the node has basically empty and clean history on its disk volume. That's why probably you need to, it's just my guess, but that's something like that usually kind of, persistence volume. Make sure that those persistence volumes are reused upon restarts of your Kubernetes pods. Probably that should be possible to do if you have some sort of shared. Anyway, go and discuss this. Like Branimir is trying to help. I think yes, like many of us experience this. It's like Kubernetes specific thing. So try to go and talk to someone, like to our Ignite experts and committers who are still at the booth. Probably they will help you to get to the bottom. But my guess is that you just need to make something with that persistence, like volume. The volume has to be reused upon cluster restarts, like upon node restarts. All right. Any other questions to Greg? Okay, looks like that's not. All right. So, like, if someone wants to talk to Greg in private, you have this opportunity in your helping menu to the left. You already, I think, are familiar with this control panel. You have the hall. Go to the hall, find the Q&A section, and Greg, I think you have 5-10 minutes, right, of your time.
Yeah, I'll be over in the hall. So if anyone has questions about monitoring, feel free to ask. If you're trying to get your clusters connected or anything like that, I can help you troubleshoot those things. And yeah, if you want to play around with Control Center, you can sign up for free at control.gridgain.com. It's a very easy way to get started.
Yeah, actually, and that's actually a good point. You don't even need to install Control Center or any other management and monitoring tool. You basically can take advantage of Control Center, like just create an account and use it, and nobody is going to charge you, at least the first 30 days, okay? And then you can decide. But generally, the tool is designed for Ignite by those who are creating Apache Ignite as well, contributing to Ignite. So thanks a lot, Greg.
Cool, thanks everybody.
Thanks a lot for coming.